Good afternoon, everyone. Thank you for joining us on time. Today's presenter is going to be Dr. Colleen Hepburn. She's been in the macadamia industry for quite some time. And I see that Colleen has already started sharing her screen. It's good to see you so eager. I would like to, before we hand over to Colleen, to state that I have had to change my view on Thrips several times since I've entered this industry, and fairly recently I've changed my my view on my stance on whether we should control them or not, or how do we control them. And let's hear what Colleen tells us. Let's take emotion out of our decisions and come with an open mind, because if we don't have an open mind, there's no reason for us to to attend these sessions. So I'm going to hand over to Colleen. I just want to allow her to unmute. Better, thanks.
Is that okay? All right. So, yes, I'd just like to thank you to Green Farm Nut Company and to Barry for giving me this opportunity to address you this afternoon. I will be talking about controlling thrips, and yes, I've had quite a few years studying thrips, and it's as Barry says, you change your mind about it the whole time. Okay, so I've been involved with macadamia research for the past 13 years, and for 11 of those years I was based in Mpumalanga province. 4 months ago, I joined Madumbi in KwaZulu-Natal, which has now been brought under the umbrella of Andermatt Madumbi. We are a biological solutions company. And yeah, so I'm looking at things from a whole different perspective now. What I've learned over the years is that knowledge is key. Macadamias are a long-term investment. When you do your research, use credible sources. Go and speak to knowledgeable experts and get all the information that you can before making a decision. Do it right from the start. There are no do-overs with trees. You want those trees still to be standing 20 to 30 years from now and also be giving good yields. Ask the right questions, use common sense, and don't be led. By asking questions, is this the best way to do something? You open a totally new line of inquiry. You improve methods and possibly come across new innovations that could be better for us in the end. When we're having a look at prepping the land, it's a very important step in the whole beginning of things. When you're doing your leveling, contours, drainage, laying your irrigation and everything, it is important to get it right. You're not going to be able to go and replant that orchard. So consider the spacing between the trees. If you plant the trees too closely together, it's going to lead to height and canopy density problems later on. It's also going to impact your spray coverage, pruning, and the light infiltrating the orchard. This is the perfect time to incorporate organic matter, to put something back into the soil. This is the time where you can build the carbon up back in the soil, and once you have planted the seedlings, all you can really do is add mulch on the top of the ridges. So having a look at this, you could also put some soil health products into the land prep. Make a point of visiting your nurseries when you're going to choose your seedlings. Visit the accredited nursery before placing your order. They also want to meet you. They want to know what you're looking for, and you can acquire knowledge from the nurserymen just by visiting and chatting to them about different varieties. You can check the stock in the nursery, see that the seedlings are healthy, pest and disease free, there's no J roots, the plants are not pot bound, and the leaves are of a good color. There's a lot of chlorotic leaves out in the orchards today and at nurseries, and what you want is the deep green cover. Check what sprays, drenches, nutrients have been applied at the nursery. So just to ensure that they have been getting proper nutrients and a good start. Ask questions about the different cultivars. And also stipulate what requirements you're looking for when you go and collect your seedlings. If you need them staked, if you're living in a very windy area, you might need your seedlings to be staked. You also need sometimes to have them all topped off at a certain height, and ask them to remove any pruning tape. This is in case there's some tiny insects like the macadamia felted cocksid, which actually, and the thrips as well, will also hide under this tape. And it's also mealybug crawlers, and that will also be under the tape. So ask that everything, the tape is removed on collection. These are some of the seedlings which are, as we can see, totally unacceptable. And in a nursery with thousands of seedlings, there's bound to be some of these seedlings that do not fit the criteria. But don't accept them. You get what you pay for. If you're going to take something that looks like it's struggling initially, why put the plant under that stress and that pressure? Rather just choose the ones, ask the nurseryman just to change them. If the leaves are yellow, please just change them for a darker green leaf. Yes, I know it's easy to fix that just by putting some fertilizer on it, but let them fix the problem. You get what you pay for. Also, on your nursery inspection, you can have a look for insects. There are quite a few species of mealybug that are present. Aphids are not really a problem. They will feed and then, they will go off and feed on something else. Thrips are always a problem. And in 2017, the introduction of macadamia felted was first identified in South Africa, and it is important to go through the nursery stock and find out if there is any of these. You don't want to transmit them back to your farm. That's bringing a problem onto your farm. And it is through nursery stock that Mac felted cocksid has now been distributed to many of our provinces where macadamias are grown. So having a look at macadamias, the hard facts, okay? A tree that is over 15 years old produces 10,000 racemes. And on each of those racemes, there are between 100 and 300 flowers. So each tree would bear between 1 and 3 million flowers. 90% of these drop. Of the remaining 10% flowers, loss from early nut drop accounts for 80%. So you're then left with a very small percent of potential nuts that will mature, and that is before disease or insect damage. It's estimated between 0.3 and 0.6 of the flowers eventually become mature nuts. So I conducted my PhD study in Mpumalanga on farms, and it was during the 2011 to 2012 and 2012 to 2013 seasons, I had a look at the botany and phenology, that's the seasonal development of macadamias, and tried to identify what thrips damage to the various growth stages looks like. So here we can see new flush, racemes, closed flowers and open flowers, the nut set, small nuts and mature nuts, and those were the stages I looked at specifically. Thrips are tiny, about 1 millimeter in length, and they have punch and suck mouthparts, and it was not possible to see feeding holes on the flowers or on the match head sized nuts because they have trichomes here on them. So even under a dissecting microscope, I was not able to find any thrips feeding points. It's not like it is one of the borers, the moths, where you can see the larvae have eaten into the husk. There's just no mark at all. So damage to the husks looks like this. It's like a scribbling or a silvering, and it does not cover the entire husk. Here we can see thrips damage to new shoot, and you can see that these are all damaged and curled back. And here's the new growth tip, which is undamaged. This browning or bronzing of a husk is actually mite damage. And here we can see, this was from Australia, this was broad mite damage. If you just put your fingertip and scratch along the side of the nut, you can see it's green underneath. So we mustn't confuse thrips damage to other damage that is out there. And one of the damages is caused by fungal diseases. So flower blight, dry flower, raceme blight is caused by fungi. And you can see here a whole lot of the little unopened blossoms have dried off and fallen off. And this people will look at and say, that's thrips damage. But it's not, it's actually a disease, a fungus. Also, irregular growth from herbicide application looks like this. If spray or drift from a glyphosate-based herbicide gets onto the bark of a tree, it can be absorbed into the phloem, which in autumn is translocated to the roots along with the sugars. In spring, when the sap rises again, it carries the glyphosate with it and causes a wide range of abnormalities, which include witch's broom, stunted growth, leaf cupping, chlorosis, and bark splitting. Here we can see an average thrips life cycle. Now, different species of thrips have different life cycle durations. This chart shows an approximation, and we can see all the various stages of development. Now, to me, the most important two stages are these two, which are completed in the soil or in the leaf litter. So to me, these are the most susceptible stages, as they are less mobile and they're in a certain place, whereas these little ones are hiding in crevices, under flowers, where the stalk joins the husk. You know, there's many places for them to hide. But here, I think this is where we should treat them. And as you see, it's only a very short period of time that they're actually in the soil before they emerge as adults. So adults live between 30 to 45 days, and the females lay between 150 and 300 eggs. So if we can stop that stage of the life cycle, we give ourselves a bit of a breather and that will encourage parasitoids, natural enemies, and other mechanisms to control thrips. So what I think needs to happen is people need to have a look at biological products. We need, as an industry, to have a look at what to apply that we can put these two stages out. And this, I would suggest, is something that a biological control that you would apply into the soil. Before the thrips peak arrives, when the blossoms are open, I would do a treatment in the soil. And then when you start to see the peak rising, I would put down another application in the soil, followed by another application 14 days later, which would mean that I would do a double tap whilst the thrips are busy entering their peak. Now, the thrips always, the highest peak in the population is when the flowers are open, and that is because so many different species are on macadamias at that time. You get those that are eating new flash, but you also get the thrips that are eating pollen, and the thrips that are eating other thrips, the predatory thrips, and you get the others that are feeding on the flowers. So if you put this part of the development out, you will have a longer period of time. And during that time, hopefully the thrips will move on to another crop once the flowers are finished and those ones that were after the flowers have gone. Then we have a lower population to try and control. By doing the application in the ground using something like an entomopathogenic fungi, this is also good for the honeybees, as you're not spraying anything when they are around. No foliar sprays of these products. So during my study, I wanted to relate the occurrence of thrips species to macadamia developmental stages. And this is a graph, a histogram, depicting the average number of thrips over both of the seasons and the average number of ip-sized nuts. So anthesis starts around the 13th of September. And the initial nut drop, that's the match size nuts, start to drop at the the end of September, and it finishes towards the end of October. Then the start of immature nut drop, or what's also known as November nut drop, begins early in November and ends early in December. The maturing nuts continue to drop at far lower levels until maturity. And here you can see the number increases because those are mature nuts from the earlier bearing cultivars. Here, I've had a look at the total number of ip-sized nuts with and without thrips damage. And I have copied across the Mac phenology from the previous histogram, so you can see when anthesis occurs, when the start of the tiny nut set occurs and the end, the start of the November nut drop and the end, and the early cultivar maturity. In the turquoise, we have the total number of ip-sized nuts, and then we have in the yellow the total number of ip-sized nuts with no thrips damage, and along the bottom here is the nuts with thrips damage. As you can see, very few nuts with thrips damage to the husks ip-sized over this time. So I also conducted a pilot study assessing yellow sticky card traps to calculate Thrips density throughout the study period, and whether this would be a practical monitoring tool. So what I found is that the cards indicate Thrips presence, but they do not reflect population dynamics. This is in part because only adults are caught. The larvae can't fly, so you will only catch those adults that are flying in the orchard. The traps are very small and only two-dimensional, so the total sampling area of the block or the orchard is just that minute little area. To me, it's impractical for orchards. All it tells you is that there are thrips there, and the numbers on the cards are very, very minimal. So, you know, you can also have thrips are very tiny. If there's a breath of wind or whatever, you know, some of them might get trapped on that and get blown onto the card. But otherwise, for them just to find that color, to find that card, it's not meaningful. And the cards are, however, very effective in greenhouses and enclosed nurseries, but this is mainly for other crops. So is damage to the husk purely cosmetic, or does it affect kernel maturity? And I had done this pilot study during my research, but with a very small sample size. So I decided in 2006, let's just do it again. And I collected 100 nuts with thrips damage, 100 with no thrips damage, and 100 random control sample. And we dried them out. So we have the dry and shell weight, the kernel weight, and then sorted them between mature and immature. And we can see of the mature, there were with thrips damage 93, with no thrips damage 94, and the control were 90. And then we differentiated them between germination, onion ring, and late stink bug, and then cracked out. So we can see the number of holes. We have sound kernel from this. With thrips damage, there were 67 nuts in total that were sound. With no thrips damage, 54. That is because the germination was so high. There were 25 nuts that were germinating. And the control random sample was also 67 nuts sound kernel. So there's no difference with thrips damage to the husk. So we also had a look at if some cultivars were more susceptible to thrips damage, and the answer was yes. There are 3 groups. The A16s seem particularly susceptible, and that goes for a lot of insect damage and also diseases. A16 seem to be more prone. The next group was Nelmac D, and then the third group was Beaumont Nelmac 2, A4, 788, and 816. So I didn't cover all cultivars. These were the only cultivars that I was using in my study. So how much does thrips damage contribute to abscission? And I was not able to quantify the proportion, as natural thinning and nut drop is part of macadamia phenology. In the 2 seasons, the amount of abscised nuts without thrips damage was 83%, and with thrips damage 16%. But like I say, there was no difference in the kernel, the crack out. In 2015 and 16, that season, there was a dramatic increase in the number of thrips countrywide, that we were all experiencing a drought, and the numbers just increased horrifically. There was extensive damage to the growth tips and new flush, And we also, the farm I was working at, we also experienced red spider mite in early December. The population was almost entirely made up of citrus thrips, and it went year round. The numbers decreased in winter, but did not go through any diapause, so they were constantly present. I decided to do another pilot study, and I had a look at tip growths that were damaged. They actually looked dead. They had brown leaves, and I had a look at healthy tips, and I marked those growth points. And then I would go back weekly and take measurements with a ruler and take photographs and just measure whether those dried, stunted, dead tips actually recovered. And after we received some rainfall, the growth tip did recover. Most of the brown leaves dropped off and the new flush was green and healthy. So one thing that I did notice is before I left Mpumalanga was a dramatic decrease in the number of thrips during this past season. And I've been trying to encourage growers to have some form of vegetation in between the rows to stop the herbiciding and to leave an alternate source of food for thrips. And here we can see this ground here has been herbicided to within an inch of its life. And here we can see new plantings where grass and other crops are grown in between the rows. And you will not believe how thrips numbers dropped this past season. So now, where are we? Many pest species are becoming less susceptible to chemicals, and this has been going on for many years now. All insects, both good and bad, are exposed to chemical spray applications. And before spraying, we have to decide what spray the active ingredient belongs. Which chemical family does that active belong to? And here we can see a couple of the chemical families, the organophosphates, organochlorines, carbamates, and pyrethroids. We need to also have a look at the total number of sprays applied throughout a season and to record that by chemical family. Just have a look at that and see if you are relying too much on any one of those chemical families. You need to also consider that some of these populations of pests move and migrate from other host plants. So, for instance, the false codling moth will move from avos to citrus, guavas, lychees, macadamias, and they carry with them all those sprays or the sprays that they have previously been exposed to. So the development of resistance, there are many ways that insects develop resistance, and this is only one of the ways. In every population, there are some individuals that are genetically predisposed and have resistant traits. And here you can see these two are the ones with resistant traits. Excessive use of pesticides of the same chemical family results in individuals without this genetic makeup dying, leaving those that are immune to continue breeding. So subsequent populations are therefore less susceptible, they become resistant to the chemical, and by increasing the dose and frequency of the chemical, you're actually making things worse. So if you have a look at an insect that has a very quick life cycle, like thrips, and they're exposed to the sprays that are not actually meant for them, but maybe meant for stink bugs, and it's consistently, let's say, a pyrethroid, they're going to build up resistance and cross-resistance very quickly. When they're exposed to chemical sprays, as I say, used for other insect pests, and more actives are being banned and MRL tolerance is declining. So we're getting fewer and fewer products left in the basket. And this is what we've been saying for many years now. The new insecticides that are being developed and registered have a lower persistence. So it's good, they're more eco-friendly, but the timing of the spray needs precision because they haven't got the extent of protection that the harsher chemicals had. So as we know right now, more actives are being banned, phased out. The latest in North America is chlorpyrifos, and it's time to return to biological solutions. We're forced to do this. And it's not to say that chemicals don't have a role to play in integrated pest management. They do. Each part of pest management is a separate section, and you can't rely on one thing solely. It has to be a combination of everything. So why I say return to biological solutions, it's because biological control agents were first used many, many years ago by the Chinese in 200 AD, when they used predaceous ants' nests to place in citrus to control insects feeding on the foliage. So this is ancient. The first insect pathogen was recognized in 1726, and it was identified on a noctuid moth. It was a fungus on a noctuid moth. Post-World War II, and that's when all the problems began, there was a production of synthetic organic pesticides, which sidelined biological control. And because these pesticides were very harsh and dropped everything, there was a whole lot of problems with mosquitoes and malaria, and it really was very useful in the day, but the misuse and abuse of it has brought us to where we are today. So where are we now? We're on a steep downhill with no brakes. In the 20th century, we saw the formulation of synthetic pesticides, herbicides, fungicides, and fertilizers, and these contributed significantly to where we find ourselves. The toxicity was not only against the target species, but on beneficial insects, the soil web, microorganisms, aquatic systems, birds, mammals, and yes, man included. And what have we done? We've pressed harder on the accelerator. We've been topping up, replacing just 3 of the 74 minerals in the soil, which is available for plant nutrition. All we do is basically top up those 3. We've only started looking at replacing the others a couple of decades ago. And soon after we started putting this pressure on the crops, the pest and disease pressure increased. So it's a known fact that there's a link between healthy soil, healthy plants, and the decline of pests and diseases. So in summary, biological solutions, healthy soils, nutrients, microorganisms collectively produce robust seedlings, which gives you vigorous plants, resilient to pests, pathogens, and disease. We need to get back to the basics, use only chemical control when necessary. The lack of susceptibility to chemical families leaves us no choice but to look at sustainable biological approach. Andermatt Madumbi also has a support app which is called Connect to Grow. The app is free to download off Google Play Store or Apple iStore. This offers information on our biological solutions, the products, labels, brochures, application guidelines, and supporting documentation. It is available both in English and Afrikaans, and queries can be relayed to our biospecialist team. All you need to do is to register, download, and have the information at your fingertips anytime, anywhere. So I think many of you have heard the term land stewardship, which involves protecting and revitalizing the land for future generations. And it's our job to correct the mistakes that have been made in the past and to do it better in the future. So I want to leave you with some wise wisdom, words of wisdom from the Dalai Lama. It is our collective and individual responsibility to preserve and tend to the world in which we all live. So I thank you for your attention, and if there are any questions.